So limit as x goes to 0 of this thing. Great. Very nice. Can you just plug in 0?
No.
No. What do you have to do in order to solve this? Give me a method.
L'Hopital's.
You have to use L'Hopital's rule. Now, what's the first thing you check if you're going to use L'Hopital's rule?
If it's 0 over 0.
It needs to be an indeterminate form, right? Or 0 over 0 or infinity over infinity. Is it 0 over 0?
Yeah.
It actually is. So do you remember what you don't have to show the notation, but remember that h thing we did? Like that. So you take it, and this is going to be equivalent to the limit as x goes to 0 of the derivative of the top, which is e to the x, what? Plus sine x minus 2 all over 2x minus 2. Now, can you plug in 0?
Yes.
Yeah, if you plug in 0 now, what is this going to be? It's going to be 1 plus 0 minus 2 all over what? 0 minus 2?
Yeah.
Is that correct?
Yeah.
So negative number like this, so it equals 1/2. Right. So the answer on this one would be C, which is actually what most of you answered. Correct. It gave you the Maclaurin series, right? So which of the following is a power series expansion for x squared over 1 minus x squared, right? So literally what's happening?
Substitution.
You're plugging in what for what? Where are you what are you plugging in where?
You're plugging x squared as x.
You're plugging in x squared as x, right? So instead of this, what do you end up with? The sum n equals 0 to infinity of something to the n. What goes in there?
X squared.
X squared, right? All that's going. How do you compare this and this right there? What's the only difference?
X squared in the denominator.
The x squared in the denominator. There's something else though about it that we haven't taken care of.
You have another x squared.
You have to multiply it by a x. Do I put an x squared here? Where do I put it?
In front.
In front?
Does it matter? Doesn't matter.
Is it the same where the point is this right here takes care of this x right here, the substitution, right? But what else is different between this and this right here? The whole thing has to be multiplied by what? Look at the top. It's x squared here. What is it over there? It's not x over 1 minus x. It's 1 over 1 minus x, right? So if we want to do this right here, I'll be more explicit. Sorry, I'll be even more clear. This right here, if we wanted 1 over 1 minus x squared, what's that going to be? The summation of from this to infinity of x squared to the n, right? But is that what we want? No, we want x squared on. So what do we have to do to both sides? Just multiply the whole thing by x squared. So if we want x squared over 1 minus x squared, what's it going to be? X squared times n equals 0 to infinity of x squared to the n. So you just have to do the notation out, right? Yeah. So do this out. When n is 1, what's the first term?
X to the 4.
No, when n is 1. Oh, so when n is 0, when n is 0, it's going to be x to the 0. What is it going to be? 1. It's going to be
X squared. 1 times x squared.
Wait, hold on, kids. When n, it goes from 0, right?
It should be 1.
What is x to the 0, everybody?
1.
1, right?
But 1 times x.
No, but not yet.
But not yet?
Oh.
Okay.
X squared.
1.
So the first one is x to the 2 to the 0, right?
Yeah.
What's the next one going to be?
X2 to the 1.
x2 to the 1. I'll write it out more explicitly. Yeah, it is. I'm just going to make it clear. Sorry. Plus x squared to the 2 and so forth, right?
Yeah.
What's out front of this thing?
X squared.
X squared. Well, what do we now have? We have x squared times 1 plus x squared plus x to the
4
plus x to the 6, right? It would keep on going, right?
Yeah.
But then what's out front?
Another x squared.
So what do you end up with? X squared plus x to the 4th plus x to the 6th x to the 8, right? So which one is it? Is it there? You see that, everybody? There were two things with Maclaurin. The big thing we did was we had like our base functions, and then we built other ones. That was essentially how we did that really cool thing with Euler's formula. E to the pi I plus 1 equals 0. You knew what the Taylor expansion was, like e to the x, and then you substituted in, and then everything went like this, folded away, and you were like, 0. Magic. You kind of remember that a little bit, maybe? So does this kind of make sense, what we did here?
Yeah.
We built it. What's nice about it is, I will tell you what's really cool about this question, is that they give you the expansion. They're like, the expansion for this is this.
Otherwise, we figured it out.
Otherwise, they have to remember, which would be a fair thing for them to ask. You need to remember the expansions for sine, cosine, e to the x, There's a fourth one too.
P
Right?
series.
ln of x, yeah, in the p series, yeah. There's a few you definitely do have to know.
I'm sorry. Put it back on the
3. So what theorem are we actually applying if we're finding the derivative of this thing? Yeah, FTC 2. It depends on what book you look at. I think yours it was 2 and mine it was 1. And who really cares? Just to call it the fundamental theorem of calculus. You're taking a derivative of an integral, right? The upper limit of integration, though, what is the upper limit of integration on this thing? It's 2x. So you have to make sure you properly apply the chain rule. That's really what's going to be the thing here. So what is g prime of x going to be here? 2 times f of 2x. Like that. Oh, does that make sense? So when you take, look, if this was 0 to x, the only thing you need to apply the fundamental theorem is you need a constant down below. You care what constant it is. No, it just needs to be a constant. But up here, you have to make sure you're always going to kick out the derivative of what's out up here. The derivative of 2x is 2, right?
So it's always the one on the top.
Correct. It's always the one. And if it's not, let's say it was, I have a question for you. What happens if it was 2x and 0? Then flip it and make it negative. Exactly. You just have to make sure it goes constant to whatever it is, and you take care of the chain rule. So now you just have to remember, so g prime of 3 is going to be 2 times f of 6. So you go to this thing, and this is f, right? Correct? What's f of 6?
-1.
F of 6 is -1. Is the answer -1? No, you want 2 times that, so it's -2. So it requires you to remember what? You need to remember what are the 4 things that you need? Sine of x, cosine of x, e to the x, and ln of x. Those are really the big 4 that are really helpful to remember in the P series, right? Okay, so in this case, when you look at this, what numbers do you, which one does it almost look like, do you think?
D or E?
x squared.
Yeah, okay, first of all, do you remember what e to the x is? I think that's the simplest one, right?
It's like x.
Can anybody remember what it actually is?
1
Plus
1/2 x
x over 1 factorial plus plus what?
3x cubed
Over 3 factorial plus.
x4.
Okay, so it keeps going, right? And for these, you might not remember them exactly. You should. But on those, are they all sequential like e to the x's? No. One of them is the odds, and one of them is the evens. So that probably means that a and b aren't going to be there because they're going to skip around, right? Do you remember? Kind of, maybe, sort of. So what are you looking for there to be inside it? You're really drawn to the what? D and e because you want the e to the x, correct? But what's the difference here? The powers. First of all, it starts with what?
X to the 4th.
It starts with x to the 4th, so there better be an x squared somewhere in there, right? And it is sequential. It goes 4, 5, 6, right? So these would be 4, 5, 6, correct?
Yeah.
But x to the 4th, but then, so yeah, if you multiply these right here by x squared, do you actually get all of those terms except, do you get most of the terms? Well, actually, you get all of the terms.
No, you have to.
But what do you have to, but go ahead.
You have to multiply by x. Oh no.
No. Because look, x squared times x squared over 2 factorial plus x to the 3rd over 3 factorial plus x to the 4th over, that gets us what we want. Almost, right?
You just have to minus.
But there's something there that we have to get rid of.
First
1 and then second 1.
We have to get rid of this, right?
Yeah.
We have to get rid of that?
Yeah. You can get rid of that minus times x
Minus
squared.
x cubed.
Yeah,
Exactly.
get rid of that
So
times
look, you have to get rid of times x squared because if you're multiplying the whole thing, the 1 is going to turn into x squared and the x is going to turn into x cubed. So which one is it?
D.
It's D. Does that kind of make sense, everybody? We know we narrowed it down to having to be e to the x because we had sequential factorials and we had sequential powers. Cosine and sine do not have sequential powers or bases for the factorials. But then what did we notice? We noticed that it had to be an x squared term on the outside, but there was this extra piece here, right? But if we multiply everything by x squared, what does the extra piece become? X squared and x what? Cubed. So what did we have to take away? Those two right there. Basically, you can think of it as, if you want an easier way to see it, everybody, what can you factor out of everything right there? You can factor out an x squared, and when you get x squared times e to the x minus 1, right?
Yep.
And that's exactly what we wanted right there. Just deconstruct it. dt is what?
0.2.
0.2. Nice. What is the rate of increase in the area of the circle? Area of the circle. So what do we want?
A.
dA
D dt.
What is the rate of increase in the area of the circle dA dt when what? When c is equal to what? 20 pi. So what are we trying to link together? Area and
Radius.
well, area when c is equal to. So yeah, and the thing is, you have to be really careful about these things because they're going to give you the wrong answer if you mix up like radius and circumference. Essentially, the question I'm asking right now is, what formula are we starting with?
A equals pi squared.
A equals pi times radius squared. Is it okay if we start here?
Yeah.
And now we're going to differentiate with respect to t. So dA dt is equal to what?
2 pi r dr.
dr dt, right? Now, does it really make you feel really nice about this?
Yeah.
Oh, it makes you feel so good, right? So what do we want here? We're looking for dA dt, right? When what is true?
When the circumference.
Oh, we know that this right here is supposed to be what? dr dt is what? 0.2. But then we also need r, right? Oh, but we know
What is 2 pi r? I guess.
circumference is 2 pi radius, right? Right? So we know that, oh, look, 20 pi is equal to 2 pi r. So r is equal to 10. Am I good? So then you plug it in there, and what do you end up with? dA dt is equal to 2 pi times what? 10. And dr dt is what?
0.2.
Which is 1/5, right?
Yeah.
So this goes away, becomes a 2. So what are you left with? dA dt is equal to what? 4 pi. Now, this is where we get to check the truth. Did we end up with an answer that's actually up there? We did. C is the answer. How do we feel about this? Change in altitude. The change in altitude, we will be integrating r of t or r prime of t? R of t dt. We know we will be integrating r of t if we want the change in altitude, right? Because this is the rate of change of the altitude, correct? So automatically, can we eliminate a couple of these? We can eliminate d and e. Now, the second thing is during which that altitude is decreasing. The altitude is decreasing when what is true?
I was just gonna say a fun way I figured this out.
Hold on, but what? Let's just finish it this way first.
The way you find decrease in altitude
Is when
is when
r
is
r prime of t is less than 0, right? So r prime is 3t squared minus. Oh, did I make a mistake right there?
Yeah.
I did, didn't I? Very good. I totally see. I would have gotten this one wrong. Good job. So r of t is less than 0 because it is the rate. The rate. Absolutely. Tricked me up. Oh, excellent. Now here's the thing. Is this a calculator question?
Yes.
Yes. So you have this cubic, and you might be like, man, I just want to factor this thing and use all these things. No, 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 no. I'm going to do the Peter Griffin thing. I'm going to like come out with like a rolled up piece of paper and like hit your desk. Like I'm going to see the thought bubble in the AP exam and be like, no, don't do it by hand, right? You type this into your calculator, you find the zeros, right?
Well, it doesn't really matter.
Why doesn't it matter?
Okay.
Hold on. Why doesn't it matter?
Okay, so it says during the time the altitude is decreasing.
Yes.
So, 3 out of those 5 start at 0. And
3 out of the 5 do, correct.
And when we look at r of t, at 0, it's going to be 6, right? Because get rid of the t.
Oh, it is 6. Okay.
So we can just kill those,
And which one's left?
and
A.
only one left is a.
That's a really good option. Did everybody understand what he just said? Like at 0, like for this one, is it at 0? Is it decreasing? No. Look, plug in 0. At 0, it's going up. At 0, it's going up. It is including 0, right? That's a great observation. So I firmly. That's great. Go on. Done.
And then that one just takes.
That's
3
awesome.
seconds.
That takes literally. The area of an equal triangle is what?
Square root of 3.
Yep.
X squared.
Side squared, right?
Yes.
That's the area of an equilateral triangle in terms of the side. You would have to kind of determine that on your own if you didn't know this off the top of your head. So there's a base here. First of all, we have y equals 2x minus x squared. If you're gonna graph this, you might want to just, it's a quadratic, right? It's x times what? X
1 minus 6.
x times 2 minus x, right? So what are the zeros of this thing? If you wanted to sketch this thing. 0 and what? 2. Yeah, you got it. 0 and 2. Is it facing up or down?
Down.
It faces down, right? Then there's a negative coefficient in front of this, and it's bounded by this function and what axis? The x-axis. So you have this region right here. Is everybody okay with that? And then it says the cross section's perpendicular to the x-axis. So where are these cross sections? Like that, correct? Each of those cross sections is the base of a what? The base of a equilateral triangle, right? So if you were to draw this, you have these equilateral triangles that pop up, right? So then there would be like another one right there and another one right there, correct? Does everybody see these? Oh, yeah, I didn't do a bad job on that. It's not bad. There's kind of like an arc right there. So the question is, what are you integrating? Are you integrating with respect to x or y?
X.
To x, and you're going from 0 to what? 2. And then what do you need? You know it's root 3 over 4 times side squared, right? What is the side squared in this case? Well, it's the upper function, which is what? 2x minus x squared, right? Minus what? 0. What is the upper bound? The function, right? What's the lower bound? 0. Could this question be redone with like y equals 6 or y equals negative 1?
Don't you have to square it?
We're not done yet. Yes, we will square it. Yes. But what I'm saying is, it goes like this, and then what do? Dx. Yes. Now here's the thing: is that something you theoretically could do by hand?
Oh, yes.
Theoretically, you could do it by hand. Should you? No. We're not going to do it right now because I want to keep going through some of these questions. But our list so far of things that we really need to look into are so let me write this function looks like. So how do you go about doing this? If you want to you need to first find m, the average rate of change, right? How do you find m? How do you do that? Literally find slope, right? It's going to be f of 4 minus f of
1
over 4 minus 1. Just going to write out the whole thing, right? So you use your calculator and you find out that's going to be. Could someone use their calculator and tell me what m is going to be? Anybody do it?
It's gonna be.
Well, it's going to be, yes. It's going to be 4 plus ln 4 minus 1 plus ln 1 all over what? 3. And what is ln 1? 0. So you end up with what? 3 plus ln 4 over what? 3. Okay, so that's your m value, right? So what are you trying to find? You're trying to find the x values. You're trying to find these x values such that when you plug them in, the derivative is the same, right? The derivative is the same. So essentially you're asking, when is the derivative of this equal to that? It is that we are applying the mean value theorem, exactly. So in this case, what is f prime?
1 plus 1 over x.
1 plus what?
1 over x.
1 over x. So what are you solving? 1 plus 1 over x is equal to 3 plus ln 4 over 3. And if you have your calculator, should you use your calculator? Yes. I mean, the big giveaway, look, the big giveaway that you're really going to have to type something into your calculator, even if you could do this by hand, look at the answers. There are three decimals, right? So use your calculator, solve it, and you should get, how many should you get? 1. It's not that bad.
You can make things a little easier when you're just looking at
Oh, you could also make it 1 plus 1 over x. See, this is why you end up wasting time on the AP exam, right? You're like, look, I can do stuff, right? So you have 1 over x equals ln 4 over 3, so x is equal to?
3 over ln 4.
That's not bad, actually. That might be...
It's probably asking to solve it.
It doesn't, but again, you still need your calculator because on the top of your head, do you know, well, ln 4 is going to be a little bit greater than 1, but how much more, right? Like, you can't do this in your head. No normal person knows what ln 4 is. Okay, I'm not making a judgment. Like, I would love to be savant level enough to, like, know natural log tables, but I'm not, and it would be really cool. So again, you did this, but the slope is undefined, which means you're going to have a vertical line. The function is, the thing is, it's not as though it's not a discontinuity, right? We know the function is defined at negative 3/8. So if it's defined there, but the slope doesn't exist, what does that mean? What kind of line do we have? Vertical line. And the vertical line through negative 3/8 is x equals negative 3. Not 2, because 2 is the time.